Yeah.
So majestic. You did. That's all I do. Jay, you're on the team with that. First one's right? It's away, right?
Like league game?
Like somebody that owns like a real and a black card and a blue card. Bro, you don't even know this. I'm doing the present the Howard standards. Yeah. They had two affairs. One of them had a kid. There's like 3 girls at once. The kid was I know. I know the fun part. Mostly because I was the only girl that was in the perfect song. As a
Oh yeah.
Is it jazz? Is the music What's the best category
Radio?
I guess me and Addie were hyping up that hill together.
Okay.
Yeah, she has something for her bachelor's kid, so she doesn't want to bring her car.
I think Jubilee burns my legs more than
What is it?
Okay, you guys might want to make sure you have 76 turned in while you're doing the minute of silence.
Today is Wednesday, February 7th.
It's under bell work.
Would you please join me in a minute of silence? Please stand if you are able and join me in the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you, and have a great day.
Okay, so a couple things to notice real quick is I do have an estimated date for our next test up on the board. It's been saying to be determined for a while here. And so I think that's going to fall at the end of next week. Of course, that's always tentative, so it could change the class period sooner, class period later. But today is actually I'm pretty sure the last new thing that we need to talk about in this unit. And then we should have a class or two set aside for review. So each of these handouts don't have too many questions on them, but these questions are a little bit longer. So for number 80, I'd like to start you off with what this is trying to do and where this thing, the difference quotient, comes from. You do not have to copy this first part down, but for you to understand why we're bothering to do this, you do need to pay attention to this part. So, all right, so if I gave you a function that was linear and asked you for the slope, hopefully you would consider doing rise over run. Or if you were given an equation, just knowing where the slope was in the equation, the coefficient of x. So you guys have been doing that for a while. But in calculus, it solves a handful of different problems. One problem it solves is the 0 over 0 that we practice for days. Another problem calculus deals with is, what if I want to know the slope of this? All of a sudden that gets to be a lot more complicated because it depends on what you're talking about. It depends on if you're talking about this point where the slope would be something positive, maybe this point where the slope would be something negative, maybe this point where the slope is 0. The slope is probably going to be in terms of x. It depends on which x value you're looking at. So in calculus we deal with this, something called derivatives, and in Cal AB at least, almost the whole first semester is about taking derivatives, how to do it, and applying them to some real world situations. Now, what that has to do with today is if I have a function, something like x squared, if I wanted to know the slope when x was 1, what we could do is we could say, well, let me pick another point further to the right, and I could find the slope of this line using the slope formula you learned in Algebra 1 and should know for the ACT. But now what if I put generic points to it? Like if I don't care that this is 1, I don't know what the function is, any of that kind of stuff. So I'm going to call this point generic xy, but instead of saying y, I'm going to say f of x. And then in mathematics, we like to say the second point has been bumped to the right h units. So this point would be at x plus h. Whatever this x value is, bumped to the right h is its new x value. And his y value comes from plugging x plus h into the function. So if I apply these two generic points to the slope formula, y2 would be f of x plus h, minus y1 would be f of x. Divide that by x2, which would be x plus h, minus x1, which is minus x. You can see that in the denominator, the plus x minus x cancels out, and then what is left behind, this is what's called the difference quotient. This is what we're going to practice the algebra behind today. Unless we change our mind though, you don't have to go one more step with this, but I want to at least show it to you because it's about 4 seconds of work, and then you know something really, really important about calculus. If I really wanted to know the slope at this instant, I want h, the second point, to be as close to the first point as possible. And in mathematics, we can do that by saying the limit as h approaches 0. This is the definition of a derivative. This allows us to calculate instantaneous rate of change. If your function has a different slope at different times, it doesn't matter. Two generic points plugged into the slope formula, reduced a little bit, and then try to make that h value as small as possible with the limit. Now again, for us, we're not going to do this part, but you guys should be aware now that honestly, you would just do one more step. You're going to do what we're going to do today, and you would plug in 0 for h and make your answer look a little bit nicer. But this is the difference quotient. So again, it's just the form of the slope formula with two generic points. So part of doing the difference quotient is you do have to have that memorized. Again, you don't have to derive it. I derived it for you so that you can see it's not just some random thing. And because h is in the denominator, we say that h can't be 0 because we can't divide by 0. So again, we're not going to do the limit part, but again, that if you were willing to do the limit step, you could do what's called the standard definition of a derivative. And again, calculus is really only three things. Limits, which you guys honestly know most of at this point. There are a few other limit things if you continue on with calculus for years. Derivatives, which again, we spend about a whole semester in Cal AB on, not just taking them. We have some shortcuts where we don't have to do this often, but then there's lots of real world applications. So like if you have a position function, you can take the derivative and then you know the velocity function. You can take the derivative of velocity and get acceleration, among many other things. It takes us a whole semester at a college level, AP level course to go over all of that. But I'm only pointing it out because it is super important for higher level math and science stuff. So step one in all these questions is going to be, you have to memorize this. So as you practice this today, you'll have a good idea if you have that memorized or not. Step two is you need to know what this is saying so that we can apply it to this function. So f of x plus h just means you go to function f, and everywhere there's an x, you're going to replace it with an x plus h. So in place of x, I'm going to put x plus h. In place of x, I'm going to replace it with x plus h. So I'm going to try to color coordinate this so you guys can see where these parts are coming from. The next part of the difference quotient says we should be taking away the function. So subtract the entire function. And then finally, divide the whole thing by h. Now, that first step of memorizing the difference quotient is not going to get any harder. It is what it is. The second step, applying it, it doesn't really matter how complicated the function is. Applying what this is saying, just plugging in x plus h, then subtracting the whole function, and then dividing by h. That second step, we haven't done anything difficult there. But now, what we have to do is we have to do the algebra behind this, and we have to simplify this as much as possible. So, this is where it's going to differentiate between the three different question types. Sometimes it's polynomials like this one, so it's going to simplify one way. Sometimes it's a radical, so after we plug in the difference quotient, it's going to simplify a different way. And then the third way is with rational functions. So there's three ways that this can simplify. I would say this one's probably the most intuitive for students because it just uses algebra that you're more familiar with. So I could do this part, x plus h squared means x plus h times x plus h. So you could FOIL that out. Just make sure that you're not squaring the x and then squaring the h. If you do it that way, you're going to miss the outer and inner part of FOIL. Again, I just did this. X plus h squared means this. So I did that and got that. Could distribute a 5. Could distribute a negative. And showing the work here is really 90% of what we're interested in. So still over h. Don't skip that step. I could distribute this negative 2. Keep the rest of all of this mess. Now again, one thing you have to be careful of here is it looks intimidating, but again, all I've done since I applied the difference quotient was I FOILed, distributed, distributed, distributed. It's long and messy, but FOILing and distributing is all I've done so far. Okay, and then we're close to being finished here. We need to combine like terms, and I messed this part up. Negative 2x squared would be positive 2x squared. This is supposed to be positive. So most of this stuff should cancel out now. It should go from being very messy to much cleaner and almost done. So plus 2x squared minus 2x squared goes to 0. Plus 5x minus 5x adds to 0. And for all three of our question types we're going to look today, they all are going to finish the same way. So that gives you a little bit of a hint once you see it once. But of the three terms left over, all of them have an h. So I'm going to factor that h out as a GCF. And your very last step is that the h's should cancel. Just like when we did limits, you need something to cancel. So what I'm looking for an answer here is that, the leftover pieces. Negative 4x minus 2h plus 5. Now again, if you took the limit of that as h approached 0, which means you would just get to plug in 0 for h, you would be left with negative 4x plus 5, which is what we call the derivative, and it's like a formula that would tell you the slope of that line for any given x. If you wanted to know the slope when x was 0, you'd plug in 0. If you want to know the slope when x is 10, you could plug in 10. And you can know what the slope is as it changes. Again, I'm only going to verbalize that today just because I think it's I don't know, it's so important if you are going on to calculus, but this is where we're stopping. This is the difference quotient. We are practicing the algebra part. So once again, let me recap this before we move on. Step 1, difference quotient's never going to change. Memorize that. Step 2, we need to know how to read this. Know what this is telling us to do, what this is telling us to do, and don't forget to put it over h. And for this question type, the type of algebra we need to do to simplify this was foiling, distributing, combining like terms, and then canceling out these h's. You could factor out the h if it helps you see it that way. But polynomials will always follow that similar pattern. Some foiling, a lot of distributing, a lot of combining like terms, factor out the h so those cancel. Okay, so now let's look at a second question type. Again, you'll get to practice all of these, so for right now, let's just make sure your notes are detailed well. Okay, so step 1 is still memorize difference quotient. Step 2 is still apply the difference quotient. So the difference quotient says everywhere there's an x, plug in x plus h the first time, then subtract the whole function, then put all of that over h. Again, it doesn't really matter what the function is, you should be applying it the same way. It's going to look different, but it still means the same thing. Now for radicals, these are not going to simplify the same way. There's no foiling to be done. I mean, I guess you could distribute, but we need a different path to simplify this. And for radicals, the trick is, you guys have heard this one recently, you need to multiply the top and the bottom by the conjugate of the numerator. We need the top and the bottom to be the same thing, so it's like we're multiplying by 1. That makes it look different without changing the size. But for this question type, you have to memorize that that's what you do to move forward. If you don't know what to do to move forward, then you're pretty much stuck there. Okay, and as scary as this looks, it's actually going to be not nearly as bad as it looks. I want to multiply these fractions together, so denominator times denominator, I'm just going to leave it h times all of this mess. And the numerator I can clean up a bit, because again, anytime you multiply something by its conjugate, it simplifies pretty nicely, which is the whole point of even multiplying by a conjugate. That's why it's such a nice mathematical trick. So first part of FOIL, the square root of something times the square root of itself is just going to give you that stuff. I'm going to go ahead and distribute the 3 while I'm at it. So square root of 3x plus h minus 1 times square root of 3x plus h minus 1 is just going to be 3x plus h minus 1. If you want to do the outer and the inner, you can, but remember in conjugates, those two always cancel out anyway, so I'm going to skip those steps. And then the last part of FOIL, a positive times a negative is negative, and the square root of 3x minus 1 times the square root of 3x minus 1 is just going to be 3x minus 1. But make sure that it's all of 3x minus 1 is negative. It's not just the first part that's negative. The whole thing's negative. Positive times a negative is negative. Now, that should be the hardest part of this question, because we are just about done here. We can distribute in the numerator. This makes a minus 3x and a plus 1. Again, I know it's a pain, but showing your work, you can't say this step is equal to this step if you don't write the rest of it down. In the numerator, most stuff is going to go away, like the first question type we looked at. 3x minus 3x goes to 0, plus 1 minus 1 goes to 0. And just like polynomials finished, these radicals should have the same last step too. And this helps you get an idea if you made a mistake or not. Because if it's not looking like it's going to finish this way, then you know that you must have had an arithmetic mistake. So notice everything in the numerator has an h. It's 3 times h. H is a factor. My denominator has a factor of h. It's h times something. So you can cancel out factors. And canceling out the h should be your last step. The answer to this what we are asking you to do is that today. Try to get to that point. So again, first 2 steps shouldn't seem harder. Memorize difference quotient, apply difference quotient. When it's this question type, you have to know to multiply the top and the bottom by the conjugate. The bottom I basically didn't have to do anything with. The top I had to FOIL, but since those were conjugates, it cleaned up pretty quickly. And then finally, last step should be dividing out h's. And again, in calculus, you take calculus in college at least, we don't have to do this in AB. We learned some shortcuts where you don't have to do this, but it is an important part of understanding what derivative is. If you took the limit as h approached 0, which basically means you just plug in 0 for h, this is what would be called the derivative, and it's like a formula to find slope. If you wanted to know the slope when x is 5, you could plug 5 into that. If you wanted to know the slope of this when x was 1, you could plug 1 into that. And you could find the slope of this function even though that slope changes over time. Okay, and then finally, the last one that we are going to ask you to practice and be able to do for us on the test is a rational function. So, step 1 doesn't change. It's still memorize difference quotient. I'll write it here since I can't see on the top of my screen. Step 2 is still apply the difference quotient the way it says. So plug in x plus h the first time. Everywhere there's an x, it becomes x plus h. Subtract the function the next time. And then put the whole thing over h. So once you apply the difference quotient to a rational function, it's going to look something like this. So unfortunately, unlike the polynomial where we just had to FOIL and distribute and combine like terms, that doesn't make sense here. Unlike the radical, question number 3, there's no square roots in here, so conjugates are not going to help either. But the good news is we have practiced this skill recently. This is a complex fraction. I've got smaller fractions within a bigger fraction. So we are going to simplify this complex fraction the same way we talked about like a week ago. I would love to multiply this fraction by x plus 8 to make those cancel, but you can't just multiply this one by x plus 8 without multiplying them all by x plus 8. And I would love to multiply this one by x plus h plus 8 to make those cancel, but you can't just multiply one of them by that without multiplying them all by that. So multiply every term by x plus h plus 8. Of course, complex fractions get kind of messy here, so you want to use up quite a bit of space. But then let's kind of see what the aftermath of this is. So in the end, I've got x plus h times x plus 8. So I guess I'll go ahead and FOIL these two together. It would be x squared plus 8x plus hx plus 8h. Again, kind of intimidating, but I'm just foiling. Just looks messier. Over here, make sure you don't lose this minus sign. Treat it like a negative x. Distribute negative x. We would get negative x squared minus xh minus 8x. And then our denominators we're going to leave alone. We've got an h plus times x plus h times a x plus h plus 8. So, not saying that that step is easy, but again, at least we have practiced multiplying by those smaller denominators recently to deal with the complex fraction. Now it's going to finish pretty similar to questions 2 and 3. A lot of this should add to 0, x squared minus x squared, xh minus xh, 8x minus 8x, and the very last step should be the same as the very last step for the other two types. The only thing in my numerator is 8 times h, and the only thing in my denominator is h times some stuff times some stuff. So these h's can cancel out, they're factors, and that leaves behind 8 over x plus 8 times x plus h plus 8. That is as far as you can go. This is what your answer would look like roughly from a rational function. Okay, so we've got to practice all three types of those, but again, it's 95% just really practicing the algebra. Memorizing the difference quotient, you can do that. Applying the difference quotient, I don't know if you'd call that algebra or not, but everything after that. So if it's this type, FOIL and distribute. If it's this type, multiply by conjugates. If it's this type, we have to get it out of complex fraction. But then all of them finish by most stuff canceling out and then dividing out h's. A lot of stuff canceled out, divide by h's. A lot of stuff canceled out, divide by h's. So they at least finish consistently. Okay, I would like you to flip the page, and I would like you to try question 5. And this is about as easy as a function as you'll ever see for applying the difference quotient. So I think it's a good warm-up for you to try and see what you do. And when you get the answer will hopefully make sense to you why the answer is what it is. So just go ahead and try to apply it and simplify as much as possible and try to get all the way down where you cancel out the h's at the end. This will be the only one I ask you to try on your own on this page. I will go over the others with you again. Even though there's similar question types, it's good for you to hear it multiple times so you can hear the consistency between questions. got stuck, or if you're not sure if your answer is correct, you should follow along with me here. So again, it's good to, for your sake, maybe write down the difference quotient every time you have to practice it. That's going to help you memorize it. Of course, I think if you do that, you probably should write the restriction too, because that's considered part of the definition. But in red here, f of x plus h just means everywhere there's an x in f, you replace it with a x plus h. Minus f of x means you're going to subtract all of f of x and then put it all over h. So again, just based on the type of function that this is why this one's going to simplify a little bit nicer, but you could have distributed the 2, distributed the negative, combined like terms. Oh, I forgot a plus 1 here, sorry. There's a lot of consistency between these questions. That's how I caught that. This was supposed to be 2x plus 1, 2x plus h plus 1. The plus 1 minus 1 goes away, and then in the end you had a 2x or 2h divided by h, so you can cancel out those h's because those are terms, which leaves you with a nice looking answer of 2. Any guesses why I said that might be familiar to you, or why that might make sense as the answer? Okay, remember, again, I guess you don't have to know this to be able to do this, but really the difference quotient is just a really fancy way to do slope. It works whether it's linear or any other type of function that has curvature to it. So you really should have known the slope of this was 2 right from the beginning. Difference quotient was consistent. No matter what x is, because there's no x's here, the slope is always 2. Linear, the slope never changes. Okay, let's practice the rest of these together, and then on difference quotient practice 1, we will do one of each type as guided practice, and then I'll give you the rest of the class to practice one of each type, I think 3 more times. Okay, so again, you really don't even need to worry about what the question's about at first. You need to make sure you know the difference quotient. Maybe practice writing it down so you can memorize it well. Step 2 is always applying the difference quotient, and it doesn't matter what the function is, that shouldn't be any harder or easier. So start off by plugging in x plus h the first time, subtract the whole function the second time, and then I know you don't need it until the end, but put it all over h. Now, this is where it matters about what type of question it is. If we started with a polynomial, our algebra to finish would be foiling, distributing like terms, combine like terms, and cancel out h. If what we had started with was a radical function, we would need to multiply by conjugates, combine like terms, cancel out the h. Because this is a rational function, once we apply the difference quotient, we're left with a complex fraction. We've got small fractions within a big fraction. So this one we need to work with the same way we did complex fractions the other day. I would love to multiply this by 2x plus 5 because that makes those cancel. But if you multiply one thing by 2x plus 5, they all get multiplied by 2x plus 5. I would love to multiply this one by 2x plus h plus 5 because it makes those cancel. But you can't multiply one of them by 2x plus h plus 5 without multiplying them all. Guess I better put this in parentheses too. X plus h plus 5. So again, to deal with the complex fraction, you're really just multiplying everything by the smaller denominators. But it gets messy, and if you are not careful, you might lose a negative sign, you might lose a piece of information here, so do that carefully. But for this first one, it looks like once those canceled, I was left with 2x plus 5. Over here, after those canceled, I'm left with -1 times this stuff. And I'm going to distribute the -1 and distribute the 2 at the same time. So it's like -2 times x, -2 times h, and then -1 times 5. Again, the messier you make your work look, the messier you make your handwriting look, the harder that's going to be. Don't make it harder than it has to be. And then our denominator just has a bunch of stuff. It has the h, it's got a 2x plus 5, and it's got a 2x plus h plus 5. Once you feel like you've gotten past that step, you should be feeling pretty good because we're almost done now. All of these questions basically finish off the same. Combine like terms, 2x minus 2x plus 5 minus 5. And then your very last step for every one of these is canceling out h. -2 times h, h times this. Timesing by h, dividing by h, those cancel. In the end, we've got this in the numerator and this in the denominator. Now, if you want to like distribute this too, you can, but there's really no purpose, so you don't need to do it for me at least. So I started off with a rational function, so the big hurdle there was rewriting it out of complex fraction form. But honestly, I was not even thinking about this type of question when we did complex fractions the other day, but I did mention that complex fractions show up in lots of different algebra stuff. It's not specific to just limits. Okay, so now let's look at a polynomial, another polynomial. So it should begin a little bit easier now, a little less overwhelming. Step 1 and step 2 are not going to change. Okay, so there's the difference quotient, and there it is applied to this function. Now, this is where it could branch 3 different ways. You might have a complex fraction like the last question, and you need to deal with that. You might have a bunch of square root stuff, and you might need to multiply by conjugates like we did on the front page. But if you started off with the polynomial, this is probably the algebra you're going to feel most comfortable with. This is just FOIL. Again, don't just square the x and then square the h. It's x plus h times x plus h. You have to FOIL it out. Distribute a -2. Distribute a negative. And then finish it like every other one. Combine like terms, and then get the h's to cancel. So if most stuff doesn't cancel out here, that's your red flag that you did something wrong, that you forgot something. But x squared minus x squared goes to 0, plus 2x minus 2x adds to 0, plus 1 minus 1 adds out to be 0. Everything in the numerator that doesn't go away better have an h in it. I don't know that you really need to write it this way, but to maybe help you, you could factor out the h, and then it's a little bit easier for you to see that the h's cancel out. So again, we don't actually do this particular skill much in Cal AB, just because they don't require it on the AP exam. But when I took Cal 1 in college, my teacher actually told us that she was going to make us do definition of a derivative by hand every single test. Of course, college classes are only 1 semester long, so. But she actually did, And this is the work that I did, except the only other thing I did was plug in 0 for h at the end. And the derivative would be 2x minus 2. If you're taking AP Calculus next year, there's a shortcut. There's a way to look at this and know that it's going to be 2x minus 2 without doing all of this work. But that being said, this is pretty consistent with calculus. You guys can FOIL, you can distribute, you can take out GCFs, you can combine like terms, but can you do 3 or 4 or 5 or 6 messy steps of that without making a mistake? And that's where people think calculus is hard, not usually the calculus concepts. Okay, I think we got one more for this one, and then we will jump over to practice 1, unless you try one of each as guided practice that I'll still go over with you. So again, this is going to be the most common type. I don't know if we will put all 3 types on your next test, but if we only put 1, it would definitely be a polynomial. I would suspect we would do either 2 or 3, but step 1, memorize difference quotient. Step 2, apply difference quotient. And on the minus f of x, I just went ahead and distributed the negative from the get-go. That makes it a little bit less later. Okay, be careful with your algebra here. I'm going to go ahead and just do all of this at once. If I was to FOIL x plus h squared, that would be x squared plus 2xh plus h squared. But I'm going to also distribute the 2. Again, if you need to do that in 2 steps, then it's more important that you take more steps and feel confident. Distribute a negative. I already distributed this negative, and then try to finish it the way the rest are finishing. Combine like terms, most everything should go away except for your h stuff, because the h's need to cancel out in the end. So 2x squared minus 2x squared plus x minus x plus 3 minus 3. Everything left in the numerator has an h. So if you want to factor it out as a GCF, if that helps you see what you're doing next, then please do that. Last step should be canceling out the h's, no matter what the question type is. So again, in calculus, we would say the derivative was 4x minus 1. But just doing the difference quotient, it's also got the h piece there. Okay, on this note page, each one of those you can see there's a little bit.ly link underneath them of somebody else on the internet working those out. So if there's any of those you would like to hear again from a different perspective, then of course you are encouraged to look at those. But of your other 2 handouts, one of them is practice 1 and one is practice 2. So if you would look at practice 1, again, we're going to do one of each question type as guided practice, and then that should help you kind of know where you stand and where you might need to get some individual help. So I would like you to try, just do question 1 first. Do it as carefully as you can. And if you get that answer right, you're probably okay with that question type. Again, there's 3 question types you need to get under your belt today. So let me give you a few minutes, and then I will go over it and give you a chance to speak up and ask questions. I guess I will also add to this. I'm going to give you several minutes here, but of course some people are going to be feeling better about this than others. I don't know what the full answer is, but I know part of what the answer is because of the calculus that I know. So in the end on question 1, if you don't end up with a 6x and a -4, then you definitely have a mistake. You should also have some h stuff, but I don't know what the h stuff is in my head. So if you finish and you don't have 6x and you don't have a -4, try to find your mistake. But if you do have those two things and you're waiting for me to go over it, you are welcome to maybe do the top question on the back page. It would be the same question type, and you could wait for us to go over that one. I'm gonna give you 3 more minutes before we have to move on. So. Okay. So if part of your answer did not have 6x and part of your answer did not have a -4, then I'm 100% sure you didn't do something correct. Again, that shouldn't be your full answer. There should also be some H stuff. I just don't know what that is. So let me go over this one with you one more time, and then that can help you wherever you slowed down or made a mistake, so that you don't continue to do that. Okay, this is what your first step should look like. It's a lot of stuff to it. It's f of x plus h minus f of x all over h. Okay, when you do this, this is going to be one of the most common algebra mistakes you guys have. And I don't know if this is still true, but one of our math teachers, he hasn't worked here in a long time, but he used to do some of our ACT prep. He told me this was always an ACT question. I don't know if it still is, but they like to see if you're just going to square the x and square the h and not FOIL it out. X plus h times x plus h is x squared plus 2xh plus h squared. Distribute the -4. Distribute the negative. It's got a lot going on here, but again, most of this is about to go away. I didn't distribute the 3. I guess to save myself from writing all this out one more time, I'm going to go ahead and just distribute the 3 right here. Okay, and now everything should go away in the numerator except h stuff, because I need to factor out a h and divide out the h. So we've got 3x squared minus 3x squared plus 4x minus 4x plus 2 minus 2. Lots of stuff went away. Of the stuff that was left, 6xh has an h. 3h squared has an h. And minus 4h has an h. So if you want to factor out one of those h's as a GCF, it's a little bit easier to see that that canceled out. So as promised, part of your answer was supposed to have a 6x, and part of your answer was supposed to be minus 4. The rest of that was a plus 3. You have to FOIL this. That's what I highlighted. X plus h times x plus h. You got to FOIL it out to the side to see where 2xh comes from. Okay. Specific questions about number 1 you'd like to ask? Any part of that looks different than mine? Again, the highlighted part would be the part that I would suspect would be 90% of the mistakes you might have made. You guys have to FOIL that out. I've said that 6 times now. I don't know how to say it any more than that. Okay, then go ahead and try question 2. Again, I'm going to go over one more of each of these with you. So this is the radical one. I think we only practiced one of these on the other page. So you'll need, this is the type you'll need to multiply by conjugates. So go ahead and give it a shot and see where you get stuck, or see if you can come up with the answer. Again, I can cheat a little bit because I know some of the calculus, but I'm 99% sure that's what your final answer should look like. So I wrote that on the board for you, so if you get that as an answer and you're feeling good about that one, you could work the second question on the back while you wait for everybody else to give it time. But once again, I'll give you 4, 5, 6 minutes here. Plenty of time to really see if you can do it, given enough time. Okay, 2 more minutes and we need to go over it to move on. Okay, if you did not end up with that as an answer, I need you to follow along with me, please. And again, you're welcome to do the second question on the back page if you did get that, because you must have done this one well. But I'm about to take that answer off because I need the space. So if you haven't checked yet, please check. Alright, so for question 2, again, you need to have the difference quotient memorized and you need to apply it correctly. So here in red, this is the f of x plus h, and purple is the minus f of x, and then all over h. Now, to simplify this one, this is the one that's not a complex fraction and doesn't just have foiling and distributing. There's more to it than that. Guys, can y'all wait, please? I can't think listening to you. Okay, this is the type that you have to know what the next step is to move forward. And the next step, algebra-wise, would be to multiply the top and the bottom by the conjugate of the numerator. So this was a minus, so the conjugate should be a plus. Remember, conjugate, you only change the sign in between the terms. Only the middle sign is the only one that gets changed. So the denominator is going to stay pretty messy. H times this stuff, H times this stuff. But your numerator should clean up quite a bit. When you multiply this numerator by this numerator, it's going to be FOIL. First part of FOIL, the square root of 3 times x plus h minus 5 times square root of 3 x plus h minus 5 is just going to be 3x plus h minus 5. I'm just distributed to 3 so I don't have to do it later. The outer and inner part of FOIL are going to cancel out anyway. That always happens when you multiply something by its conjugate. And then the last part, this would be the part I would be most concerned about you having a mistake on. The square root of 3x minus 5 times the square root of 3x minus 5 is 3x minus 5. But it's a positive times a negative, which means this is negative. Not the 3x. the whole thing. If you only make the first term negative and not the second term, then that's something completely different. So this is really like minus 3x plus 5. Now it should finish pretty consistent with the other questions. 3x minus 3x adds a 0, plus 5 minus 5 adds a 0. Everything in the numerator has an x in it. Everything in the denominator has an h in it. Everything in the denominator has an h in it. So that last step of the h's cancel out should be there. And then in all of this mess, 3 is the only survivor of the numerator. And then the denominator has all of this stuff that we just couldn't do anything with. That's where I had gotten that as an answer. Okay, any specific questions about what I did on this one? Any of the algebra that you don't see what I did or you did not think to do? Okay. All right, then we need to do one more as guided practice because there's a third type. So this is a rational function. After you apply the difference quotient, you're going to need to do some other different algebra skill. So go ahead and try question 3, see what you come up with, or at least where you get stuck. And I think I can probably tell you what the answer is going to be. Okay, maybe not. I don't know if I can do that in my head. Thank you. Okay, so try your best in the next 5 minutes, please. I'll have to work it separately, and I'll share the answer when I'm done, but I'll race to work. I did it very quickly on my screen and erased the answer, but I'm 99% sure, unless I just did something too quickly. I think that's what you should end up with on number 3. Again, I'm only sharing that so that if you feel good about it and you have that as an answer, you're not waiting on everyone else. And you could do the third question on the back. Of course, you could also apply the difference quotient to a lot of other function types. We just pick these 3 in particular since they're the most common. These would be the only types you would have to worry about showing up on your test. It's been 5 minutes, so if you did not get that far in 5 minutes, then let's see what you should have tried differently, please. Alright, so difference quotient's never going to change. How to apply it's never going to change. So this is what you should have started off with. Okay, now the only way to simplify this, because it's a complex fraction, is to get it out of being a complex fraction. So basically multiply by all of the smaller denominators. This needs to be multiplied by 3x minus 2 so that those cancel. So everything gets multiplied by 3x minus 2. This one needs to be multiplied by 3x plus h minus 2 so that those cancel. So everything gets multiplied by 3x plus h minus 2. So once everything has been multiplied by those two things, what's left over here is 5 times 3x minus 2, or 15x minus 10. Over here, I would say probably the most common mistake on this entire question is losing this negative here. So negative 5 times all of this would be like negative 15 times x, negative 15 times h, and negative 5 times 2. And we can't do much with the denominator, so just carry it along. So now that it's out of complex fraction form, now it should be pretty consistent with how the rest of them finish. Most stuff in the numerator should add up to 0. There should be a factor of h in the numerator that could cancel out with a factor of h in the denominator, which leaves you a negative 15 in the numerator, and a 3x minus 2 times a 3x plus h minus 2 in the denominator. Again, there's no need to try to distribute or FOIL that denominator. It's not going to simplify anymore anyway, so don't take the time. Okay, do you guys have any specific parts of this you'd like me to go back over with you? Anything you didn't do right and you're not seeing why I'm doing it the way I'm doing it? Okay, so again, that's it. That's the 3 question types. So on the back of 81, I'm going to make one little tweak here to our schedule. But on the back of 81, you need to practice one of each type again. And I had you pick up 82, which was different quotient practice 2. I'm actually going to take that off your homework list. We spent a little more time on this.
Will we eventually do it?
Yes, we will eventually do it. So if you guys have downtime and advisory, or your classes are longer now, so you might have some more downtime. So I will ask you to do the second worksheet that you picked up today, but you don't have to have it done before next class. You do need to have number 81 finished. You do need to have difference quotient practice 1. So that might just be one more of each time on the back. And of course, while all of this is fresh in your head, it would be a good time to circle or highlight or write yourself some notes about some stuff that you might want a reminder on about. So finish up 81 and make sure I have 78 in Google Classroom before next class. This is a B week, so this is the last time I see you guys, so you probably won't think to do that over the weekend, which is why you should probably do it before you leave. But again, I believe that to be the last thing of this unit, so we'll get to practice this a little bit more in worksheet 2, and we'll have a test review for you, and just trying to make sure we clean up and pull all these different parts together so you guys feel confident about your next test. I did record questions 2 and 3 on the front page that I will add to the website if you'd like to hear those explanations again. And remember, the notes page has all of those individual links made. Those videos are made by other people, not me. So if you feel like you need to hear the explanation again, you got lots of options this time. those of you that are choosing to move on to the difference quotient practice 2, even though I didn't say you had to before Monday, but if you are, there is solutions on the website that have all the steps. So feel free to check your answers as you should, but also comparing your work to that work should help you see if you missed something and help you clear that up. Okay, and with our new bill schedule here, you guys still have about 20 minutes. As always, if you have a math question I can help you with, you're welcome to call me over or bring it up here.